Hey, what's going on? Right here we're looking at the 3.2 notes and simplifying radicals. Alright, you just finished your warm-up, so now I'm going to guide you through the instruction. The product rule right here. Alright, notice that we have two radicals, alright, with the same index, A. Alright, it has the same index, so they can both be square roots, third roots, cube roots, fourth roots, fifth roots, etc. If it's the product of two radicals that has the same index, you can combine or multiply the terms underneath the radical. So right here, the a root of x times the a root of y equals the a root of x times y. And here's an example right here. We have the square root of 10 times the square root of x equals the square root of 10x. The quotient rule, alright, again, tells us if we divide, alright, the radicals are the same, they have the same index, and we divide the terms underneath, we can apply the radical to both of them. Alright, we don't have to leave the radical over the top and the bottom. We can extend the radical to both of them because it's the same radical. Here's an example. You have the square root of 10 divided by the square root of 2, which equals the square root of 10 over 2, which is the square root of 5, because 10 divided by 2 is 5. Alright, so right here on this first example, it says express each radical as a simplified form. Alright, well, in doing so, when I express it as a simplified form, what you end up doing is you're doing the opposite of what we did in that example. Right here, we need to factor this out, and we got to figure out two factors. Alright, 48, and let's hope that one of them is a perfect square. So if you think about your perfect squares, you like to write them out. So 1 is a perfect square. 1 times 1 is 1. 2 times 2 is 4. Alright, 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. Alright, 7 times 7 is 49. But anyway, when I look at this radical 48 right here, one of these perfect squares is a factor of 48. Actually, two of them is in this case. If you look, you have, we can break this apart a couple different ways. Alright, I could do the square root of 16 times 3. Right? I could also do, if I did it this way, I could do the square root of 4 times the square root of 12. Right? But see, there's a perfect square in this one. Alright? The square root of 4 is the square root of 4, but 12 breaks apart to the square root of 4 times the square root of 3. So anywhere it go, we're going to get the same answer. I'm just showing you different ways to do it. The square root of 16 is 4, and then you have the square root of 3. That one's done. Alright, that's the answer we want. But if you went this way, a little bit more steps right here, because the square root of 4 times the square root of 4 is the square root of 16. And then the square root of 16 is 4. Alright, so I did this to show you that you want to pick the largest possible perfect square. Alright, that's a factor of the term underneath to break that apart. Alright, now if we look right here for 450, let's see if we can find a larger perfect square to go into this. Alright, so I think what we could do is, let's see here. Alright, so right here, the square root of 450 can be broken apart to the square root of, let's say, 25 times the square root of 18. Alright, and then we have the square root of x to the 4th. And we have the square root of y. I'm going to break this y to the 5th up as y to the 4th times y to the 5th. Because if you remember yesterday, if you add those exponents, oh, I'm sorry, I just realized I made a mistake. Here, let me fix it. Square root of y times y to the 4th. There we go. Alright, because 1 plus 4 is 5. Anyway, the square root of 25 is 5. This 18 breaks into the square root of 9 times the square root of 2. 9 times 2 is 18. So the square root of 9 is 3. And there is no square root of t. Well, it's a really long decimal. Now, the square root of x to the 4th Alright, the square root of x to the fourth, remember, that's the square root. So the square root of x to the fourth would be x squared, because x squared times x squared is x to the fourth. And then right here, the square root of y to the fourth is y squared. And we have radical y underneath the radical, because you can't pull that one out. And then we simplify everything outside. So 5 times 3 is 15. X squared, y squared, square root of 2y, like that. Alright, for number 3 right here, it's the same concept. Except notice that there's a negative out front, so that's okay. When we break down that 675, I'm sure there's a perfect square within 675 that we get. Alright, let's see here. So we have the negative out front. So we're going to break this 675 apart. Let's see, 675. I think 25 is a good bet. So let's go 25 and 27. And then we have m to the fourth. N to the 11th. I just like to break it all up, guys, so I can see it. Alright, p to the fifth. Alright, square root of 25 is 5. The square root of 27 is the square root of 9 times the square root of 3. So the square root of 9 is 3. Now we have the square root of m to the fourth. Alright, when you take the square root of an even value, just cut it in half. So the exponent in half, cut the exponent in half. So that's just m to the squared. Alright, n to the 11. Alright, n to the 11. N to the 11 can be broken up into square root of n times square root of n to the 10th. I'm going to read that again. Square root of n times the square root of n to the 10th. See, that's 11. So now, remember I said, just cut that in half. The square root of n to the 10th is n to the 5th. I still have the square root of n right there. And then finally, p to the 5th. Again, we can do the same thing with p to the 5th. We can go square root of p times the square root of p to the 4th, because that's 5 p's right there, or p to the 5th. So we have, remember, cut that 4 in half. The square root of p to the 4th is p squared, and then square root of p. So now just combine like terms. So 5 times 3 is 15, and to the square, m squared, and to the 5th, p squared, and then put your radical. And we have radical 3 and p. That's simplified right there. So now with that being said, I want to give you an opportunity to make or try it by yourself. All right, try it by yourself.